thing. This is a mechanical power hammer that I built recently over the winter, and I've been putting it to work quite a bit, and at this point I feel like I can really talk about it and go into detail on it because I've actually used it and now I know how well it works. I want you to know that there's nothing particularly, at least I think, there's nothing particularly special about this power hammer that isn't different from any other power hammer build that you see on the internet these days. A lot of the stuff you're looking at here, I just kind of copied everything that I've seen, as well as other machines that I've used myself over the years that were professionally made things. I'm sure there's way better ways to do these things, but I was just doing what I could with what I had. This hammer has about a, I'd say 55 to 60 pound ram weight ram. Removable dies that come out with a bolt system. It's a flywheel driven by a 212cc Harbor Freight Predator engine. The fact that I don't have a whole lot of electricity out here really did push me over the edge on building my own rather than buying one, because I could buy one and then I wouldn't have electricity to power it, or I could buy one and then try to find a gas motor to switch that over. And I would like to do that one day because I think that would make sense, and I don't think people really do that often. I never see it. But at that point I thought, you know, I'm sure I could probably build this for a lot cheaper. With that being said, I think I maybe spent around maybe $2,000 just on the materials alone. Cheapest like used power hammers that I can see on Facebook Marketplace these days, at least in my area, they're running about at least $4,000 for a hammer that's very heavily used, and I wasn't really interested in going down that road at that point in time. Now, while I've shown all of this to you, I can't honestly say that I condone this kind of behavior, just building a machine out of garbage and going to the scrapyard and just building something like this, because this thing is dangerous. This thing's really dangerous. There are so many parts of this thing that you could get your fingers caught in, or that spring could come out and hit you in the head. And even if you have like safety protocols, like it is really dangerous. So I'm saying, I'm not saying that you should build one of these. I'm just saying that, you know, I'm not promoting that. I'm not encouraging that kind of behavior. So here's the basic concept of how mechanical power hammers work. Again, there's probably way better ways to do this, but this is the general idea. You have a motor with a small wheel on it. Small wheel is important. That's probably maybe a 4-inch wheel. And it takes this V-shaped belt. That's just a regular old lawnmower belt you can get at Napa. That belt goes up and around a 19-inch wheel. This was the biggest wheel that I could find, but having now built this, I know from experience and from other people telling me that the bigger the wheel, the better. So if you can get a bigger wheel than 19 inches, you get 20 or even 24 inches, you're just gonna get more torque. Small wheel spins fast. Small wheel sends torque to the outside of this wheel, and the distance between where the belt connects and the shaft is much longer here than it is down there. That creates a lot of leverage going to the center of the shaft that is able to create torque output on the end of this shaft. So this shaft is just sitting on some basic pillow blocks. I ended up adding a third one because this one was sticking out way too far and I wasn't happy with that. I was afraid it was going to bend, so I added this later on, and now it's supported. The front here is just a big old sprocket. It was the only thing I could find that was steel because I knew I needed to weld on it eventually. So I welded the front and back of the cam rod that this pillow block sits on. That's just a regular old piece of 1-inch thick by 3-inch thick or 3-inch wide piece of flat bar that sticks out the end there. These linkages were just made of whatever kind of flat bar that I had laying around. Some awful welds on there. Don't look at those. The spring, that's the spring from shock on a car. Gave that to me for free. They have so many of those things lying around at that particular scrapyard. They just gave it to me for free. And it was quite an ordeal to compress that enough. I had to use some ratchet straps and pry bars to compress this enough to get that threaded rod in there. But that's what we're looking at there. That is, I don't know what that is. It's got to be about 3 inches in diameter. this coil here. And then it was a pretty long one. Gonna have to compress it quite a bit to get it there, but I'm happy that I did have to compress it that much, because this ram is pretty heavy, and this spring is barely able to do what I needed to do. So the ram slides up and down between some angle iron. So this is 3x3 square mild steel, and I have these mild steel pieces of angle iron that run down the center of it. Centered those up the best that I could. And then the slide guides are just another piece of angle iron. I keep that very heavily greased, knowing that's just going to wear away on that. And in the back here, I have a system of bolts that allow me to adjust the tightness of that, the tension on it. Probably one of the biggest issues that I have with this model and the way I built this, because these really don't work that well. It works, it's just not that amazing. Because these slide guys are so basic, the ram does kind of rock a little bit, and it does affect the forging down here, making it so the dies don't come together completely flat. But the die sets sit in these little channels, and they're bolted down. What's cool about this setup is it allows me to remove and replace it very easily. Also allows me to have much bigger dies than I would have had to if I had just the surface area of the underside of this 3x3 square. I would have had like really tiny dies, and that would have been really frustrating long term. So I went with bigger dies, and because they stick out past the ram, it does come up and hit the top of this every once in a while. This whole ram has about a 6-inch stroke to it. That's because the closest I could get this cam rod to the center of that was about 3 inches. That's because when you come to the back here, that's as far as it would go, because this collar is there, so I couldn't make it go any further. Professionally made hammers like Little Giant, they have maybe 4 inches of stroke of this size. The stroke can be adjusted in a couple different ways. One is loosening and tightening the bolts on this threaded rod that allow the linkage arms to compress the spring even more, allowing the ram to hang even lower. So you can start lower or you can start higher by allowing it to move out more, and it straightens these linkages here, so it brings the ram up higher in its resting position. So you can have a higher resting position, but that's only just like a little bit of adjustment that allows you. Down here, this die system gives you a lot more adjustment of height and stroke and its starting position, because you can just take out this spacer or add another one up top. Or if I was working on forging a blade, I usually put my other 1-inch spacer up here, and I have the dies pretty much touching each other. And when I'm forging really small stuff, that tends to work out a lot better. And then when I'm forging really tall stuff, I can actually just take all the spacers out entirely and work that way. I can also just take out these forging dies entirely and just have the top of the anvil and the bottom of the ram come together, and they kind of work like flat dies for some things. This is an interesting part. The treadle here pulls down on this linkage that pulls down on the clutch wheel, and that's how you engage the drive. When it's loose, the belt is loose enough that that wheel just slips, and that can create a lot of heat if it's a little too tight and it's not quite, like it's touching it, but it's not quite engaging it enough to get the wheel going. It can rub it up quite a bit and actually burn the belt, so you have to be able to adjust it just right to get it to a point where it's not tight enough and it's not burning the belt, and then when you push down on it, it really engages and does pull that wheel. Again, if you had a bigger wheel up here, bigger diameter wheel, this would work a lot better. This is a whole complicated setup. This don't think about this too much. This was just a thing that I found. This frame already had bearings and the drive shaft and the wheel attached to it, so I thought I'll just use that. So this is a little bit more complicated than it needs to be, but it's what I had. So I have a threaded rod here that allows me to line it up with the belt in this direction. Got a little locking screw on that, and then I can unscrew that and tighten or loosen the treadle, and that brings that treadle up or down depending on what I need. That helps me to prevent from bottoming out on the treadle before I actually engage the wheel. So if I'm forging away and I'm starting to lose a little bit of the connectivity on that, it's not really engaging on it, I just come over here and tighten this up a little bit, raising the treadle, and then I will have better connection there. That whole arm just pivots on this pin in here that goes straight through the I-beam. I have another pin over here that connects to a spring, or connects to a turnbuckle, which connects to a bunch of regular trampoline springs that connect to a little U-bolt I got down there. So being able to adjust this means I can adjust the angle at which this sets at, so I can make it rest up higher, I can make it rest down lower. This is definitely me just making it work. These bolts in these slots allow me to adjust the height of the engine, and then this turnbuckle allows me to adjust the angle that the wheel sets at, and in turn the entire engine as well. Then there's actually slots in this angle iron that allow me to slide the engine back and forth and adjust it to get it just right. Every kind of adjustment that you can make or offer yourself is going to get you a lot closer to lining everything up. You can actually have this wheel system really offline and it'll still kind of work without like derailing itself, as long as you're running this like triangular shaped belt, because it wants to stay in the track pretty well. The last thing I want to talk about is this brake here. This is once again another thing that I wasn't entirely happy with, but it does work, and I was working with what I had. That is a little saddle I made out of metal that I wrapped leather around. That's just like cowhide leather. And you notice that when I push down on the treadle, this welding rod is bent around a hose clamp that is connected to the body of this clutch wheel system. And when I pull down on it, it pulls down on the welding rod that then pulls down on that mild steel rod, which has a spring on it that engages it with the bottom of the wheel, and that leather comes in contact with it. And when I pull down on the treadle, pulling down on the clutch and engaging the wheel, at the same time it pulls the brake off of the wheel. And then when I release it, it disconnects from the belt and then reconnects with the wheel. There's a little stud that I welded in there that keeps it in track so it doesn't spin. And believe it or not, that ridiculous thing actually works. It actually works really well. It slows the wheel down quite quickly and gives me some sense of control on getting it to stop when I want it to stop. It's still a very unwieldy machine, but honestly, I'm proud of it. It works. The concept is there. I hope one day to build another one, because it was honestly a fun exercise in figuring out how to make this thing work. I got a whole lot of other ideas that I want to try as well that this kind of gave birth to.